method. I put linear regression method because time series analysis can be computed, can be analyzed using various approach. It can be analyzed using what we call the average method, using what we call the moving average method, the moving average method. And that is not being tested as much in ICANN. It's tested in, I'll say it can be tested in what is called the foundation level. Yes. And but it's good you know them. It's you trying to compute your average from given data. So what in simple time, what is time series? Time series analysis involves studying data points collected or recorded at regular time intervals. Collected or recorded at regular time intervals. You can take your notes, because sometimes I might just speak off what I have in my slide. So time series analysis involves studying data points collected or recorded at regular time intervals to identify patterns. Take note of that word, patterns, trends, or seasonal variations. So in a question, they can give you a data monthly. They can give you data quarterly. So you need to identify the pattern, the movement, for example, in the cells of an organization. During the winter period, how is the cells? During the summer period, how is the cells of this organization? So time series analysis is used in forecasting based on what has been happening over time. Can we look into the future to determine what will happen in quarter one of 2026? If quarter one of 2025, of 2024, of 2023 have been this way, let's see, since this is the trend, because this might be our peak period as an organization. So let's plan ahead of 2026 to see how we can make more sales, more profits, more revenue for the organization. So time series, I said, involves studying data points. Now, in the elementary statistics class, everybody have done statistics at every point in time, and you'll be asked, what is a data? You say data are raw facts, and for data to become meaningful, they must be arranged into an organized way, and they become an information. So data or time series involves studying data points collected or recorded at regular time intervals to identify the patterns of the data, the trends in the data, or if there is any seasonal variations. So one of the simplest and most commonly used techniques is the moving average method. The moving average method. And when we talk about a moving average method smooth out short-time fluctuations and highlight longer-term trends or cycles in the data. Now, when you're trying to solve questions on moving average method, if the data given is in even number, it means there are two steps you have to take. Because when you're trying to get a midpoint in an even set of data, you won't be able to get a perfect midpoint. But if it is an odd number, for example, 1, 2, 3, the midpoint will definitely fall at 0.2. But when it is an even number, 1, 2, 3, 4, the midpoint will be between 2 and 3. So most times, you need to do two-step workings when you're trying to solve for an average that involves even number. Well, I'm not going to talk or dwell too much on that. That is not the subject matter of this class. I'm just saying that for you to have a background knowledge of what that entails. Our subject matter in this class is to talk about linear regression. Linear regression. Now, talking about time series using linear regression. Time series analysis with linear regression involves modeling. It involves modeling the relationship between time and a dependent variable. So when we model the relationship between time and the dependent variables, we try to identify the trends and make a forecast. So most of us have been hearing the word linear regression over time. Some of you have done research work that you need to analyze your data using ANOVA, using Strata, using SPSS. And when you use SPSS, you see these options of linear regression, ANOVA, and the rest of it. But I want to ask at this point, I want to get reactions from the class to get your view of what linear regression is. If this is not your first time of hearing that word, let me make everybody, if you want to talk, can just raise up your hand. So I call you to talk. Let me allow everybody to have access. I want to learn too. Yes, when I come to class, I like learning, not just me talking and talking. Now, if you know what linear regression is, you use it. You've analyzed your data with it. Yes, can you just share your idea on what linear regression is? Anybody?
Sir, what I know about linear regression is I'm Chinyere Ogumike. Is that linear regression is one of the techniques used in cost separation.
Okay, cost separation. Okay, fine. Yes, somebody else. Everybody, most of us are graduates here. I know you. Most of you are social science students. We only have few science students here. So, once you're a social science person, you should know what you should have. And some of you are master students, PhD students on this platform. So,
Good morning. Hello, good morning. Can you hear me?
good morning, I can hear you.
Okay, it's a data analysis technique that predicts the value of unknown data by using another related and unknown data value.
Okay, yeah, that is fine. Yes. Okay. All right. It's okay then. It's let me talk about that. When we talk about linear regression, linear regression, linear regression is a statistical method used to model the relationship between two variables by fitting a straight line to the observed data. Now, the purpose of linear regression is to predict the value of a dependent variable, which in most times we represent as y, based on the value of an independent variable, which we represent as x. So we have the linear regression equation. Please, you can write it down. So it's in this slide, but please write it down. The linear regression equation is y equal to a plus bx, y equal to a plus bx. Now, what is this y? What is y? Write it. You know how to write. When your math teacher is teaching you, you say where, colon, you write y. Y is equal to what? Y is the dependent variable. Y is the dependent variable. In brackets, you can put predicted value. Predicted value. And x is what? X is the known value. X is the known value, or rather, you can put in brackets the independent variable. Independent variable. As most times, if you are trying to do a research work, your supervisor will ask you from your topic, what is the dependent variable? What is the independent variable? Because there must be a relationship at a point. So now your x is the independent variable, you can put in brackets the known value, and your a is what? Your a is the intercept. Your a is the intercept. Intercept. That is, what is that intercept? It is the value of y when x is 0. The intercept is the value of y when x is 0. Please take note. Take note of all this. When we start solving, I will be bringing out some elements, and I want you to use these values, these definitions, to point out the variables in the question. So I said A is the intercept. A is the intercept. What is that intercept? It is the point where you get the value of y when x is 0. If x is 0 in the equation, that is, when x is 0, 0 multiplied by b will be 0. Then y will be what? Be the value of a. Will be the value of a. And y will now be what? The intercept. The intercept. Now, what is b? What is b? B is the slope. B is the slope. And what is the slope? I need a question. I need a response again. Most of you have done. Mind me, I like asking questions. And so, what is a slope? Can I get some hands up before I turn on my mic? You know, some people can be in traffic and their noise can be disturbing us here. Yes, Adebayo, you can speak.
Okay, slope, from my understanding, is that how much y changes. I mean, that's dependent variables, how much it changes for each unit increase in that x.
Yes, yes, that is it. Thank you very much. That is it. So another word for slope can be termed as gradient. Gradient. So slope is change in y for 1 unit increase in x. Slope is change in y for 1 unit increase in x. That is why for those that have done advanced maths, that is further maths, for you to get a slope, you'll be doing change in y, change in x. That is where differentiation and integration set in. So the slope is gradient. And what is that gradient? It is the point where change in y for 1 unit increase in x. That is the slope. Please don't mind all what this grammar I'm saying. It's not, when you see question on time series and linear regression, they are very simple and straightforward. But the point is, you must know what to do. And that is why I've decided to set up this extra class, so that when you see question on time series, you should be able to attempt it. Because the formula is in the question paper. The formulas, they are there in the question paper. I know most of us don't take our time to check. Maybe if this is not your first time of writing this paper. I know most times when you finish, you just throw your paper somewhere and say, these people are wicked. And you just throw it and fling it somewhere else. Because I was in a class with someone yesterday, and I was asking her, "Where is you have your question paper?" She said, "No." Anytime she finish, she pray, and she doesn't come to write this paper again. I say, "Okay, that is fine." So when you have the question paper with you, you see some of these formulas there. So this is just statistics. Statistics. Your ability to know the value to use per time and substitute them in the formula is what you need to know. Then this equation line that I've mentioned is very key. Y is equal to A plus BX. Y is equal to A plus BX. And you must be able to know the interpretation. Said Y is dependent variable, X is a known value or independent variable, A is intercept, value of Y when X is 0, and B is slope, that is change in Y for 1 unit increase in X. All I'm saying, they are not in the slide, so please, I need to write them, or if you don't, you can watch the video again. And now, what is the purpose of using linear regression in time series? What is the purpose of using linear regression in time series? Number one is to identify trends in the data. Already stated that in the definition, and to forecast future values, and more so to quantify the rate of increase or decrease over time. Over time. So let me speak to my slide. Let me see what is in my slide. On my slide, I said it is the technique that produces a line of best fit for the observed data. It is a statistical method used to model the relationship between a dependent variable and one or more independent variables, assuming linear relationship exists, yes. So it fits a straight line to a data set, allowing for predictions and trend identification. These are all the stories I've been dishing out. Now, for you to solve questions on time series that involve linear regression, there are two models. There are two models you need to know. What are those models? Don't mind the word model. We have additive model and we have multiplicative model. Why is this coming in here? Take note, there will always be seasonal variation. It means the cells in quarter one will vary from cells in quarter two. Cells in quarter two will vary from cells in quarter three, and so on and so forth in that order. So when we have variations, and in the question, the variation value is given to you as just a figure, you do what we call additive, you use additive model. But where the value, the seasonal variation value is given to you in percentage. Okay, sorry, I'm just seeing a message. I think Germany is somebody said I should activate something. That is what I'm trying to say. Yeah, Mr. Eniola, is that okay now? You can just send me a message via the chat box. Let me know the way you've done. All right, it's okay. So when you're trying to solve questions, sorry, you didn't frame your question well from the chat box. I can see a question. You didn't. So is it purpose of using linear regression in time series or vice versa? Can you please rewrite again? Yes, but let me go on with my class. So additive model is used when the seasonal variation is given as a figure, just as a number, or where the seasonal variation is given as a percentage or decimal. You use multiplicative model. Multiplicative model. Now, the additive model, what constitutes this model? We have the trend, the seasonal variation, the cyclical variation, random variations. So, but the most important you always see in question is trend and seasonal variation. So, when you have your trend value and you have your seasonal variation figure given in the question, what you do for additive, if it is just a figure, you add, you plus. But when it is a percentage, what you do is you multiply. For example, I can say the seasonal variation in Q1 increased by 6%. When it increased by 6%, it means you are adding, it will be 106. But when it decreased by 6%, it will be what? It will be 94%. So take note. So what for additive, if the figure is just 20 and not percentage and not in decimal, what you do is to add. So we're going to see that in a question very soon and see how that plays out. So you can see that this is the additive model. This is the multiplicative model. Y is equal to T times X. C and CR. This C and R, cyclical and random, they are not always present in the question. So it will always be the trend and the seasonal variation. Now, please, these are the steps to solve time series using linear regression. These are the steps. This formula, don't be scared, they're in the question paper, but I know you've not been checking. So steps to solve time series using linear regression, but it will not be bad if you can know them and have it at your fingertip. Somebody will say, where is the time? The exam is here already. Yeah. If you would actually want to do something, you create time to do it. So steps to solve time series using linear regression. Now, number one, determine the trend equation. The trend equation is the first thing you need to do. And the trend equation is what? Y equal to A plus BX. Now, in some questions, they will give you the value of A directly. They will give you the value of A straightforward. But what is A? What do you know A to be? We said A is what? A is intercept. You see in the question, like the question I forwarded yesterday night, you can see in the question that intercept is what? Is also value. So in some questions, you will need to solve for A. And when you have to solve for A, this is the formula. This is the formula. Summation Y divided by N minus B summation X divided by N. That means for you to solve for A, you must first determine the value of B because you need the value of B to determine A. So for you to determine B, and we said B is what? B is the slope. Where B is not given directly in the question, you will need to determine the value of B. And how do you determine the value of B? It is N summation XY minus summation X multiplied by summation Y divided by N summation X squared minus into the bracket of summation X squared. Now, what is N? N is the number of observation you want to look into. If you want to look at 5 quarters, N will be 5. If you want to look at 10 quarters, N will be 10. The value of X are the actual values given in the question. If they are not given directly, they're not given directly, but in most times they'll give you these values. Yes. So all you need to do is to substitute this value into this formula and you work. So once you can determine the value of A and B, the X will be the sales value that you need to input in this equation to see the change that will occur in Y. To see the change that will occur in Y. For example, if I'm to look at the change in the first quarter, and I already have my A and B. If my first quarter is 1, I'll place X as 1. So once you do all this, you estimate the trend value using the trend equation determined in step 1 above. So calculate the percentage variation of each quarters. And if the data is given to you monthly, you calculate the percentage variation monthly. Percentage variation is actual sales divided by trend values multiplied by 100, where you are required to do that in a question. So this is just a repetition that Y is a dependent variable, A is the y-intercept, and B is the slope of the regression line, and X is the independent variable. So when you talk about independent variable, what do we mean? Let me even get your reactions to that. So I've made mention of that, but somebody might still be wondering, what is this dependent variable and independent variable? Yeah, somebody wants to speak to that. The floor is open. Grace.
Good morning, sir. Please, I have a
Morning.
question.
All right.
Okay, in the question paper, ICANN question paper, this formula stated
Yes.
on the slide is saying the linear regression equation of y on x. Is there a x on y or something? There's another formula.
So in the question paper, I want to get your question right.
Yes, sir. In the question paper, this formula you included on your slide.
Yes.
Is there in the question paper as the linear regression equation of y on x? So my question is there another formula for another regression equation, maybe x on y? Or this is the only formula?
It depends on the interpretation. You know, you can write this formula in another form. You can make y something else, but you must know what y is. You know, all these are just expressions. Yes. If I should change this y to w, I must know what w is. I must know the interpretation of w, right? The point is, all this can be put in another form. But what you need to know is the interpretation. Do you get that? That
Yes.
A will always be what? The slope. And if this is not A, if this is D, you should know D will be the slope. So what you need to do is the interpretation of the formula. So once you know the interpretation and you apply it rightly, it's fine, irrespective of the alphabet here, you understand? But on a general palace, this is how to be expressed. Yes.
Okay, sir. Thank you very much, sir.
All right. Yes, Chibi.
Sorry, sir, please just help us explain percentage variation again. I think I missed it.
Okay. Now, percentage variation is how much a value has changed relative to its original value. Yes. So it is the actual sales divided by the trend values. Now, the trend, take note, the trend are changes that have occurred. The trend, the actual sales in quarter one, the actual sales in quarter two, the actual sales in quarter three. What are your observations? What are the changes between this period? What are the changes that have occurred between this period? So those are the trend values. Those are the trend values. So, but to get it in percentage now, it is the new minus the original value divided by the original value. Just like you trying to do a percentage change. So when it comes to variations in quarters, what are those changes in the various quarters or in the various months? So it measures how much a value has changed against its original value. So in a question, if the sales in quarter one is 100 and the percentage variation in that quarter is 6%, it means you multiply that sales multiplied by 6%. That is, it means the sales have increased by 106. So when you're talking about variation, the main point is 100. If the seasonal variation increased by 6%, it means the sales have increased by 6%, the original plus the additional increase of 6%. If it has reduced by 6%, it means that you are now working based on 94%. It means you can get the 6% of your original sales and less that decrease of 6% from the original sales to get that seasonal variation based on the question. So it is a change. The new value minus the original value divided by the original value multiplied by 100. I don't know if that is fine. You can just put a message on if you're okay. This is a question. This question is a very long one. One thing with time series question is that they can be lengthy, but if you know what to do, you can do it in the space of 30 to 45 minutes, and you'll be fine. So can somebody read this question? One of the co-hosts, can you just read? Let's see how we can solve it.
Okay, can I read?
Yes, sir.
Some time ago, Robert launched a new product some years ago. At first, sales were good, but now the figures are causing concern. Robert wants a more accurate sales forecast to produce detailed cash forecasts. Since there is some seasonality present in the raw data, the series for sales shown below represents the underlying trends based on an average process the year, quarter, trend points, sales cartons. 2016, 2017, 18, quarter 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Trend points X 1 to 10. And the carton and the sales cartons. On average, quarters 5% and 6% respectively above trend waste quarters 2 and 4 are respectively 2% and 9% below trend. Some preliminary calculations on the above 10 observations have been carried out and the results are summarized below. Results from 10-period observation, linear regression, y equals to a plus bx, slope 82.67, intercept 10.472.33, coefficient of determination 0.535. It is required to make forecast is sales for quarter 3 and 4 in 2019 and for quarter 1 and 2 in 2020. But there is some discussion on whether the 10-period data shown, the next slide please, shown above are suitable for forecasting or whether only the last 5 periods will provide a better basis for forecasting. Linear analysis of the last 5 periods only gives the following intermediate results. Results of the last 5 periods of observation. Summation y equals to 555.10, summation x squared 330, summation y squared 61.627.440, summation xy 4442.15. Note, the y value has been scaled down by 100 times for ease of calculation. Required. Forecast the sales of the 4-quarter required using the 10-period observation results. Prepare similar forecasts based on the last 5-period observation. C. Explain which forecasting basis produce the better forecast. Thank you, sir.
All right, thank you very much for that. So looking at this question, we need to determine the values that will make up our trend equation. Our trend equation that we should forecast the sales of the 4 quarters required using 10-period observation. The point is this: what are those 4 quarters required? You must know that. Let's go and analyze it. The 4 quarters required are what? From the question that it is required. Take notes so that when we start solving, we won't have too much questions. It is required to make forecast of sales for quarters 3 and 4 in 2019 and for quarters 1 and 2 in 2020. Take note of that. Take note of that. Now, that we should make forecast of sales for the 4 quarters required, because one thing when answering question, please, you must be able to identify the subject matter in the question so that you not just wander around in the hall. That is one very important thing. You go to the hall with strong faith and confidence, and not allow any fear to set in. Yes, one thing with exam is you pass in your mind first before you go to the hall. You pass in your mind that I'm going to pass these exams. When you exercise fear based on what has been happening over time, it's not good. So don't give a room for fear. Yes, overcome fear and go in the might of God. So forecast the sales of the 4 quarters required using the time period. The 4 quarters, you've identified them. What are you to do? Based on the trend, do you have the 4 quarters here? Based on the trend. Now, you only have, if this data stop here, 218. 218. Now, they are now telling you it is required to make a forecast of sales for quarters 3 and 4 in 2019. And for quarters 1 and 2 in 2020. Somebody will say, what is this again? What did they want me to do? It's very straightforward. Now, looking at this now, 216, third quarter of 216, the trend point, the X value is what? Is 1. 216, the fourth quarter, the trend point, X value is what? Is 2. You can see it consecutively following each other. In 218, the fourth quarter is what? X value is 10. Is 10. Now, the next quarter will be what? Will be first quarter of 2019. You complete this table for you to be able to answer this question here. You complete it. You update it. So the next quarter will be what? 2019. 2019, first quarter. The X value will be what? 11. Will be 11. Take note of that. Will be 11. The next quarter will be what? 2019, second quarter. The value will be what? Will be 12. Will be 12. So what you will now be left with is your ability to compute the value of sales for each of those quarters. And the value of sales is the Y that you need to determine. The Y that you need to determine. So now, okay. So please take note of that little explanation there. Take note of that. That is the first thing you need to do. You update this table. You update this table. Then when you update, you get the somebody is asking the year. Somebody should respond, please. So you update this table. Well, let's see how we can do that. I should have arranged my table before now, but I won't take much time. Since we are much, I'm teaching one person, the person that will be doing it. I won't need to arrange any table. Okay, I need to get the question so that I don't have the question. Let me get the question. So please, if you have the question in your book, start writing those data down. We need to update the data we have in the question. So write it down. I want everybody to, if you have your book, I can find that. Okay. All right, fine. So we have it, the year, the quarter. We have the trend point, which is our X value, which is X. We have the cells in cartons, which is the value of Y. Yes. So now we have the years 2016. The third quarter of 2016, the trend point is 1, and the sales is what? 10,000. I'm just trying to show this so that's 2 is 10,790, and this is 217, and this first quarter of 217. The trend point is 3, and this is 10,920. And for 217 again, the second quarter, trend point is 4. Third quarter. This is 1150. And fourth quarter, trend point, we have 6, and then we have 11,080. So 218. Yeah. So I think okay, let me just complete it since I've started. And the first here we have 7, 11,085. To 18. Second quarter, we have it as 8, and this is 11,095. And 218, the third quarter, we have it as 9. This is 11,120. And 218, the fourth quarter, we have it as 10. So this is the 10 values given to us in the question. We need to do an update. The next quarter will be what? We have 219. First quarter to be what? 11. We don't know the value of what? Of the cells. Put question mark there. Don't know it. I need to know it. So you can continue, please. The next one will be 219. I should have used Excel. And the second quarter of 219 will be 12. Do you know the value of X is no? The value of Y is no. You don't know it. Okay, I'm just trying to use my. So for 219, third quarter to be 13. You know the value of Y? It's no. And for 219, fourth quarter, this will be what? 14. You know the value of Y? It's no. And the next quarter will be what? The next quarter will be 2020, first quarter. And the value of X will be what? This will be 15. You know the value of Y? It's no. You need to determine that. So the next quarter will be what? Will be 2020, second quarter. I think that is where the question wants us to stop. 16. Then we have it. Do you know the value of Y? Is no. That it is required to make the forecast of sales for quarters 3 and 4 in 2019 and for quarters 1 and 2 in 2020 years. So that is where the question wants us to actually stop. So please, if you look at this now, you know your X values. You know the value of your X for the required month we are to solve for. We are to solve for this period. For this period, rather. For this period, that is third quarter of 2019 to second quarter of 2020. So for us to do that, in the question, they've given us certain value. They've given us certain value. The Y is what? Y is what? Y is A plus what? Plus BX. Now take note, in case for those who are just joining, for us to estimate the trend in the data, the equation of a trend line is represented as Y equal to A plus BX. You said A is equal to what? A is intercept. B is what? B is the slope. B is the slope. Now, in the question, do we have the value of A and B from the question? In the question, do we have the value of A and B? The answer is yes. The answer is yes, because A is what? Intercept. And B is what? Is slope. So you can see it given to you directly in the question. That is for the 10 period observation. We'll see if we have same values for 5 period observation. So for the 10 period observation, we are giving the value of A and B free of charge. Now, so for us to solve this now, what are we going to do? What are we going to do? If Y is equal to the value of A is given as 10,472.33, and the value of B is given as what? 82.67. But we don't know the value of X. We don't know the value of X. Monica, can you just put your write-up on the chat box? We don't know the value of X. Now, if you observe, from this table we try to update. From this table we try to update here. The value of X is the consecutive values in the, as given in the trend points. Now, for us to get the value of cells of Y now for the third quarter of 2019, what are we going to do? The X value for 2019, the third quarter is what? Is 13. It's 13. So what you need to do is to substitute 13 here into the X value, then you get the value of Y. Get the value of Y. Let's present it in an orderly manner. Let's present it in an orderly manner. So now we have it as this. We have year, we have quarter, and also let's say we have the trend. So 219 quarter 3, the trend for you to get Y will be equal to what? Be 10 472.33 plus what? Plus 82, which is the slope, 82.67. The value of X in 219 quarter 3 is what? Is 13. See it here, 13. The value of X, 13. And you substitute. Instead of writing X, you write 13. So when you multiply, you get the value of Y. You get the value of Y. So the value of Y, when you multiply, it will be what? That is 82.67 multiplied by 13 plus 10,472.33. You're going to have what? Going to have 11,547.04. Are we following? And I get emojis if there are reactions, if you are following, so that right. So for still 219, we have to look at quarter 4. Quarter 4. The trend is Y equal to 10 472.33 plus 82.67. The value of X is what? It's 14. You get the value of Y. The value of Y will be what? 82.67 multiplied by 14 plus 10,472.33. And then you have to have the value of Y to be 11,629.71. I know we can have approximation issues, but just be consistent with whatever decimal points you've adopted. So for the next quarter, which is 2020, quarter 1, Y value of the trend line is 10 472.33 plus 82.67. Now, what is the value of X? Somebody will ask, maybe I just joined. Where are you getting this X from? See it here, trend point X. So you have it. First quarter of 2020 to be 15. And we have it as this 15. We multiply 82.67 multiplied by 15 plus 1047.33. Please take note, when you're doing this, you do multiplication first before addition. Don't go and add, then you multiply. You follow the rule of BODMAS. You won't start saying, I'm getting a different answer. So yes, somebody is asking what happened to first quarter and second quarter of 2019. The question, I don't know if you've actually gone through the question. I made emphasis on that before solving that. Look at this point very well, that it is required to make forecast of sales for quarter 3 and 4 in 2019 and for quarter 1 and 2 in 2020. But there is some discussion on whether the time period that are shown story. So what we are asked to do, if you think you have time, you can still go and solve for quarter 1 and 2 of 219. To not add any mark to you. Go straight to what they've asked you to do, and you have to save your time, because in the exam hall, you think you have sufficient time, but suddenly you hear 30 minutes to go. So go straight to what they want you to do. So when you multiply this, you're going to have what? 11,712.38. And also for 42 of 2020 to be what? Y equal to 10,472.33 plus 82.67. We have it, the x value there will be what? 16. And we have it as what? Multiply. It's going to be 16 by 8267 plus 10,472.33 should be 11,795. Please confirm my figure. I'm not very sure. So these are the value, the sales value for the quarters we've been asked to solve for. When you go back to the question, there's something else here in the question. Let's follow the question. That's on average, quarters 1 and 3 are 5% and 6% respectively above trend. It means anywhere you see quarter 1, it has been observed that there is 5% increase above trend based on analysis, based on the trend. Maybe that used to be the peak period of the organization. Now, 6%. Anywhere you see third quarter, there will always be 6% based on average. There's 6% increase above trend. It means 106%. This is 105%. Whilst quarter 2 and 4, respectively, it means anywhere you see quarter 2, the trend has been that there will always be 2% below trend. Means in this case, it will be 98%. 2% below trend, 98%. And fourth quarter, anywhere you see fourth quarter, the trend has always been 9% below trend. 9% below trend. So now, based on this we've computed, we need to adjust for seasonal variation, because these trends are subject to seasonal variation. They are subject to seasonal variation. And for you to adjust for this seasonal variation based on the average given in the question, what are we to do? I would like to get response now. What are we to do? What are we to do if
Hello, sir. I think we will let the one in quarter 1 and 3, we will add it by 5 and 6%.
okay, is it addition now?
Yes, sir.
Okay. You know, I said if it is in percentage, though there are various, yes, you know, there are various ways you can do it anyway. But to make it easy, you multiply. Yes, I can see from the chat box, they're giving me the response already. Yes, 1.06, yes. So it's very nice, yes. So I can see from the chat box the response, yes, it's multiply. Yes. Just put your questions on the chat box and Mr. Uche, I've been seeing you raising your hand up since. I hope the hand is not paining you at this point. Mr. Uche, you can just put your message on the chat box, please. And put your hands down so that I won't always get distracted by this hand that is up. Okay, maybe you don't even know the hand is up. So now we need to adjust for seasonal variation. Adjust for seasonal variation. So what are we going to do now? So where seasonal variation is given in percentage or in decimal, you multiply. Multiply. So let's just present it in a table again to make it clearer, to avoid adjust for seasonal variation. And we have the years. The years we're looking at. We have the quarters. It's seasonal adjusted cells. Seasonal adjusted cells. So for 219, quarter 3, the result we have is what? For the cells, it's 11,547.04 multiplied by what is the percentage increase for quarter 3. Go and check it in the question. Check it in the question. For quarter 3, we'll have 6%. 6%. So 6% means that the actual trend is 100. 6% increase is 106. So 106%, when you multiply, you're going to have what? You're going to have what? You have 12,239.86. That is the value of cells when you adjust based on the season. You know, you are trying to make a forecast now. So 219, quarter 4. The actual cells is, based on what we've computed, is 11,629.71. Now, in quarter 4, what usually happens? You check the question. We are not manufacturing this percentage. In quarter 4, we always have 9% below the trend. 9% below the trend. 9% below the trend will be what? Will be 91%. And when you multiply, you're going to have what? We have 10,583. Please confirm. 0.04. Now, for the next quarter, 2020, quarter 1, our computation cells, we have 11,712 multiplied by, what is the seasonal occurrence there? Quarter 1, what usually happens? Quarter 1, 5% increase, 5% above the trend. 5% above the trend means that 105%. Some people might want to do the primary school method of looking for 5% of 11,712. When you get the value of 5% of it, you now add it. You know, some people like it that way. If we like working in those patterns, you can do that. But simple analogy is this. And life goes on. Because I know somebody's already thinking in that direction. Yes, it's fine. So, quarter 2, the value 11,795.05 multiplied by quarter 2. What usually happens there? Let's see it. Somebody will now say, what are we doing? Quarter 2, 2% below trend. 2% below trend. And interpretation of that is multiplied by 98%. And you have is 11,559.14. So this is adjustment based on the seasonal variation. But what is the question even asking us? Have we answered the question? Let's see. That forecast the sales. Forecast what? Forecast the sales. Forecast the sales of the 4 quarters required using the 10-period observation. We've answered the question. We forecasted the sales of the 4 quarters required. The question actually make it clear the 4 quarters we are to solve for. And the 4 quarters are quarter 3 of 2019, quarter 4 of 2019, quarter 1 of 2020, quarter 2 of 2020. That is why we've solved for the 4 quarters. And using the 10-period observation results, we used the observations given to us in the question after we've updated it. And that is how we answer the question for A. For A, if you're in this class and you don't know what we've done, let me see your hand up. Okay, Emily, let me give room for you to speak, because you mustn't attend this class and must not know what we are doing. It's not good. Yes. So, can you speak?
Okay, good morning, sir.
Yes, good morning.
Okay, sorry, sir. I'm just joining the class.
You are just joining. I are raising up your hand, ma. You know, if it is a normal Nigerian school, the lecturer will ask you to stay outside. Because
yeah, I understand, sir. Sorry.
But Emily, if you are just joining, I will plead with you. You can just relay with me even outside this class. Don't let us go back, or you watch the video again, please. You know, we don't have time.
Okay,
some people are at work. They are just stealing the office time to
same
join.
here, sir. That's right.
So some people are multitasking now. So don't let us go back, please. Let's be very free and fair. Yes. But
okay, sir. Thank you.
you can just reach out, so you watch the video again, and you'll be fine.
Okay,
Omolara,
thank you, sir.
Good morning, sir. Yes, sir.
Yes.
Okay, my question goes, well, sir. I noticed that for 2019, you did make calculation for quarters 1 and 2. You skipped quarters 1 and 2. You went to quarters 3 and 4. Would there be any penalty if there's no result for that?
No, ma. There won't be. The question made it clear. Clear, ma. Yes. There won't be any penalty, ma.
Okay,
Yes.
sir. Okay, sir. All right, sir. Thank you, sir.
Thank you, ma. So let's move further because it's morning. And some people want to catch up with certain things. And so what is the part B saying? Prepare similar forecast. Prepare similar forecast based on the last 5 periods observation. Do you have 5 periods data? Yes, this is it. Result of last 5 periods observation. See it here. See it here. Result of last 5 period observation. that we should prepare similar forecast, similar thing that we've done in A. We should repeat that using this 5-period observation. Using this 5-period observation. But the thing here is that unlike the 10 period where we're giving our slope free of charge, we're giving the intercept free of charge. For this last 5 period, we're not giving. We are only giving the components that will make us derive B and derive A. Yes, we are just giving the components summation y, summation s square, summation y square, summation xy. So what are we to do with all this? What are we to do with all this? That is the question. What are we to do with all this? Now, what we are to do with all this, I said this equation is very key. This is a trend line equation. Where is it? This equation. Now, for you to get the value of A, there is a formula. We've shown it at the beginning of this class. For you to get the value of B, there is a formula. Before you can get A, please, you always solve for B because you need B to solve for A. Yes, based on the formula. Everybody in this class, write out this formula if you've not done that. You will do it. You will do the workings yourself. I will guide you in doing it. Now, for you to get B, write this formula down. If you've not put it down, write it. Then we'll guide ourselves how to use those variables. It's just for you to substitute. There is not any big deal here. Yes. For you to get B, n summation xy equal to summation x multiplied by summation y, n summation divided by n summation x squared minus summation x to the bracket of power of 2. So please write it down. We want to get B based on 5-period observation. We've solved for 10. We want to get for 5 period. But what they've done is they didn't give us the value of A, just like that. They didn't give us the value of B. So we want to get the value of A and B. Then we now substitute into the trend line equation, which is y equal to what? A plus bx.
Can we see the equation again, please?
Is it the formula or the question?
The formula, sir.
So please write it, where B is equal to n summation xy minus summation x multiplied by summation y. Please, if you have the past question, not the pathfinder now, that's one they used to give to us in the hall. That's question paper they used to give. Please, if you have it, you can check for these formulas. It's good you know them. Check for them and see. I saw a question just now that, so to complete the first table, are we using the adjusted seasonal variation value or the first workings we did? To complete the first table is the first working. You can see you use the first working to complete it. That is the value of y. That is y. So the value of y is now being adjusted based on the seasonal variation. Based on the seasonal variation. Where is it? You can see it. When you substitute your x here, you get y directly. You understand? So the value of y, this y, for you to complete the first table, you go and put everything in this the first table here. Yes, so there are seasonal variation associated with these quarters, and that is what we've solved at this point here. The variation, that is it. So if you've put down the formula now, from the question, please, you have to work side by side with the question. If you don't have the question, have it. I know some of you might be minimizing and using your phone, but at this point, everybody should have a Pathfinder. Hard copy. You need to have it hard copy. If you are working with the soft copy, it's not too good. You have it, you scatter that Pathfinder, pieces it, and you now know, yes, you want to wonder you can. If you are working with soft copy, it's not too healthy. You have the hard, even me, I have my hard copy. So it might not be updated, but I like looking at it in the documents. You know, you might want to support the concept of environmental sustainability by not deforesting our environments by using soft copies. But for exam purpose, just get your soft copy and your hard copy and use it very well. Now, if you put down the formula, the value of n will be what? Let me get response. Omolara, please put down your question in the chat box, please. The value of n will be what?
5.
5. The value of n will be 5. Now, the point is, somebody is asking, why is it 5? The number of period, the number of observation. That's result of last 5 period observation. The number of observation, the number of period is 5. So n will be what? Will be 5. N will be 5. Based on that formula you've put down. Take note of that. Now, the next is summation xy. Summation xy. Summation xy is given to us in the question as 4,442.15. So to now be what? 5 multiplied by what? 442.15. That is cleared. Minus summation x summation y. Do we have summation x in this data?
No.
The answer is no. The answer is no. So how do we get summation x? How do we get summation x? What we do is this. Let's go and see it. Let's go and see our table from the question now. From the question. The last 5 period. The last 5 period in this question is what? The last 5 period in this question is what? 1, 2, 3, 4, 5. That is 217 fourth quarter, right? 217 fourth quarter. What are the value of x for all this period? What are the value of x when you add everything? It will be 6 plus 7 plus 8 plus 9 plus 10. So summation x will be what? Will be 40. So 6 plus x plus 8 plus 9 plus 10. So these are the last 5 periods. So the value of x for this period, you add everything together, we give you summation x, which will be what? 40. 40. Which will be 40. Yes. So now, that is summation x. I'm trying to explain the formula and follow it as I'm explaining it. Now, the next is summation y. Summation y is given to us free of charge as 555.10. The examiner know what to do. They know the values you'll be able to get. They know the ones you won't be able to, you understand? So the question will be balanced, to be a balanced question. So it's now left for you, the students, to know what to do. Now, summation y is given as 55.10, and that is it. So what next? Let's look at the denominator. We have n summation s squared. N is 5, it has been established. Summation s squared is given in the question as 330. Fine. Minus summation x squared. Summation x squared. Summation x is what? Summation x is what? Take note, is different from E summation x squared. You know this in the formula, we have it in brackets, right? Where is it? In the formula, yes, you can see it's first summation x first. Summation x that we determine is what? 40. Then you now square it. You now square it. You know, somebody can just fly and go and use this one. Summation s squared. There are different things. That is why we have to put it in formula as in brackets as summation x first. And when you get the value of your summation x, you now square it. And that is why that will be 40. That will be 40. So let me see if I can show it for everybody to see and follow. Okay, have I solved it before? No, we not solved it before. So we're trying to solve for the B parts. For the B parts that forecast based on the last 5 period. Two. Okay, some people are already there giving me the answers. Yes, but let me just quickly solve because everybody might not be on the same page. Yeah, so for this, it will be for this, it will be 40. And this is multiplied by 55.10. And for this, we have it as what? 5 multiplied by 330. For this, we have it as 40 squared. So when you simplify this, please, you must be very careful while you're trying to do this. Sometimes students you just juxtapose the whole thing and not know what to do part-time. So the results should give you, when you simplify further, the results should give you 6.75 divided by 50. I think you should have 0.135. 0.135. That is for B. That is the value of B. Please try and compute it on your own, maybe even after this class. Yes. Now for A, the formula to get A is what? This is it. Summation y divided by n minus b summation x divided by what? By n. Divided by n. So what do you need to do now? Summation y is what? On the question. Summation y is what? Are we given? Summation y, yes, we're given. See, it's 555.10. And the number of period is 5. Then b is what we derived just now. And summation x is what? Is 40. And then, so it's a straightforward thing. So since you have b now, you can now solve for A. You can solve for A. Yes. So to get for A is this formula, summation. So we have it as what? 55.10 divided by what? N. N is 5. Minus B. B is what? We just computed for B as 0.135 multiplied by 40 divided by what? Divided by 5. So when you simplify this to be A equal to what? You should have 111.02 minus what? 1.08. And A will be equal to what? It should be 109.94. So you can see that you are gradually trying to get these. You're gradually trying to get these, the values to use in these. Now, but take note, there's a statement in the question that we need to look out for. That, where is this statement? Note. See, it's note. The y values have been scaled down by 100 times for ease of calculation. The y values. What are the y values? The y values include A and B. So if they have been scaled down by 100, for you to return them back to their original state, you multiply them by 100. Yes, you add 100 to it. Yes, you add 100. They've been scaled down by 100. What does that mean? It means that the value of B here, you need to return it back to its original state. How do you do that? You multiply this by 100. That is B equal to what? 0.135 multiplied by 100. And when you do that, you should have 13.5. And for A, these are the values of Y. Multiply this 109.94 by 100. And you're going to have what? You should have 10,994. You should have 10,994. So now, can you substitute these values into this equation? When you do that, you're going to have what? The regression line equation. You're going to have what? Y will be equal to what? The value of A is what? Is 10,994 plus 13.5x. 13.5x. Please, if you're on the same page, can I get reactions, emojis? Let's know that if you don't even know what we've done up to this point, can I get maybe thumbs down? Say this thumbs down. so that it's early morning. You should be fresh. Yes, I like this early morning class. It's might deprive you of some sleep, but I think it's better off. All right, everybody, we're on the same page. Now, what are we? Okay, somebody is giving thumbs down. Faith. Where is Faith? Uche. Oluchi. My people from the east. What is happening? I hope the weather is friendly there. Yes. Can you just send your questions to the chat box? Those of you giving thumbs down, let's know what is happening. And somebody is asking, what period are we using for the trend equation? We've solved an equation with 10 periods. Now we are solving for 5 periods now. Yes, we're solving for 5 periods. When we've derived the answer for the 5 period, the C part is now telling us to compare the results of 10 period and 5 period. So that is where we are. We're trying to achieve that. So somebody is asking, please, why do we multiply A and B by 100? I clearly stated that. Always listen to my expressions. Everything I'm saying is very important. See, the question is saying, note. The Y values have been scaled down by 100 times for ease of calculation. It means they were formerly reduced. You understand? So for you to return them back to the original state now, you multiply by 100. You multiply by 100. Yes, that notes. See it, notes. It's bolded itself. Bold the character for you. That the Y values have been scaled down by 100 times for ease of calculation. So when you see note, it means there is a pointer there. So when you get the value of Y, what are those components of Y, A and B? You multiply them by 100. Yes, to get them back to their original state. And that is why it is like that. Somebody said you are fast. It's morning, we have to, before my office people come and start knocking at my door. Let me do fast now, finish. Yes. So that is why I'm a little bit fast. Yes. But we can't be too slow too. We are too slow to be much more boring. And yeah, so now that we've determined the values of Y, we've known what A is and we've known what B is. What are we to do? What are we to do next? What are we to do? Blessing, is it that you want to tell me what to do so I can allow you to speak? Or you have a question? Okay. Let me hear. Blessing, can speak?
Okay, sorry. Good morning, everybody. Good morning, sir.
Morning.
When I actually saw this, I used 10 times 40. That's more like I used 3 plus 4 plus 1 plus 2, which gave me 10. Then I multiplied by the number of quarters, 4. Is that acceptable? Or I still have to go by that 6 points plus 7 plus 8 plus 9 plus 10 to get 40?
Yes, you have to go by that because those are the last 5 periods. Those are the last 5 periods. You know, sometimes you can make error and your error can look right based on that particular question. But when you are faced in another situation, that error will not conform to the right thing. Yes. Sometimes there will be coincidence. whereby what you are adding the wrong thing, but you are getting same results with what is in the question, what is in the solution. But that is not the principle. That is not what the question wants you to do. But coincidentally, you are getting same results. So when you are now faced with another scenario, the whole thing will now become glaring that yes, the principle have been wrongly applied, or what the question wants you to do have been wrongly applied. Yes, so you have to add the 5 last period based on what the question suggests and based on what you're working with. Yes.
Okay, thank you, sir.
So now, who will tell me what to do? We've determined our values of A and B. And what the question is saying is that, let me go back to the question. I want it to be very clear to everybody. The question is saying, prepare similar forecast based on the last 5 period observation. Prepare similar forecast based on the last 5 period observation. Now, since we have the value of our Y, we have the value of Y, right? The various values of Y. Now, in the question that it is required to make a forecast, we need to now make a forecast of sales for quarter 3, for quarter 4 in 2019, and for quarter 1 and 2 in 2020. So I just need one person based on this statement, based on what we've done for A. What are we to do?
Hello, sir. Good morning.
Sorry,
Good morning,
I think
sir. Good morning, everybody.
Sorry, just 1 minute. Hello. Hello. Just if you want to talk, just raise up your hand so that I'll call you at my end so that we won't have conflicting voices. Yes. So. Please, if your background is noisy, just mute yourself. Don't worry. Once you get the idea, there is no issue. You might not need to talk. But Dolapo, can you just speak?
Okay, thank you, sir. Good morning, sir. Good morning. I think what we have to do is similar to the first one, but now instead of what we just need to do is to substitute the equation of Y that we have gotten into 13, 14, 15, and 16 respectively, and we are just for seasonal variation of the sales, just as we have done in the number A requirement.
Yes, that is it. That is just it. That is just it. Now, that is just it. So, Fumi, you want to add to that?
Yes, sir. I was thinking we'll use the last period from the from the 2017 fourth quarter to 2018 fourth quarter. But according to what she just said now, that means we are using 2019 third quarter to 2020 second quarter. We'll impute the X value in the formula we've gotten to get our Y value for the sales.
Yes, that is it. That is it. So everybody, if you have your book, quickly do that. Quickly do that. You don't just come to this class and hear my voice and then quickly do that. I will just call somebody randomly.
Okay, so sir, we have to draw, not to do a forecast table again, right?
No, you use that same, what you just need in the table is the value of X. Is the value of X. The value of X in 2019 third quarter is what? Where is it? 2019 third quarter is 13. Just substitute 13 into 13. The new equation we have. Then you get the cells, the value of Y. Then for is it for the 5?
Sorry, sir, I'm a bit confused. I don't know if you can explain me again.
Okay, at what point are you confused? So that you get confused.
Okay, like at this point right now, So they said we should substitute this y into the 13, 14, 15, 16. So what I'm now asking is that, are we going to do the table all over again? Like, because they said we should compute for the last 5 quarters.
No, this is the question. That you have 5-period observations. This is it. 5-period observation, right?
Yes, sir.
In the first instance, we use 10-period observation, isn't it?
Yes.
To forecast for 4 quarters. Now, the B part is now telling us that we should prepare similar forecast. On what basis are you preparing for forecast? What has the question tell you about forecast? The question has informed you about 4-period forecast, isn't it? 4 period. And what are those periods? Quarter 3, quarter 4 of 2019, and quarter 1 and quarter 2 of 2020. The 5 you are seeing there is just the period of observation. The 10 you are seeing here, is the period of observation. But what we want you to do is that the question has made it clear that it is required to make forecast of sales for quarter 3 and 4 in 2019 and for quarter 1 and 2 in 2020. 4 periods. So you identify those 4 periods in this table, though most of these periods were not given in the original table. So we now updated the table that, okay, 2019 first quarter will be 11. Since we stopped at 10 in 2018, fourth quarter, the next quarter in 2019, second will be 12. You understand? So now, since you've determined the value of A and B based on 5-period observation, what will you do to get Y? What you will do to get Y is to substitute the value of X for the third quarter of 2019. The value of X for third quarter of 2019 is what? Is 13. Is 13. So just pick this 13 and go and substitute into this equation of the line, the regression line. The equation. Where is it? Yes, you pick 13. You substitute here. That is for quarter 3 of 2019. For quarter 4 of 2019, what is the value of X? You pick it. It will be 14 because it's consecutive. It will be 14. You place 14 here. You get the value of sales, the forecasted sales. You understand? For quarter 4 of 2019. Now, for 2020, it will be what? It will be 15. You substitute 15 here as the value of X. You multiply, you add, you get your Y value for that period. So that is what they ask us to do. Not 5 period. The 5 period is the period of observation. But what period do you need to make forecast for? You need to make forecast for quarter 3 of 2019, quarter 4 of 2019, quarter 1 of 2020, quarter 2 of 2020. So that is what they want you to do. So I can see some answers already. Yes, it's fine. Yes. We'll do seasonal adjustment too. Yes. So go ahead to do seasonal adjustments. But let's just show it for everybody to be on the same page. Let's see. Where do we stop now? Okay, yes. So we stopped here. This is the Y value. So let me show it again in a table. Show it in a table. So we have quarter. We have the trend. Let me put it here. Y is equal to 10,994 plus 13.5. x. The year 2019, quarter 3, the trend will be what? Let me place this here. It will be y is equal to 10,994 plus 13.5. This will be 13. And the result will be what? Should be 11,169. Please try and solve this or follow what we're doing so that when it is you alone, you will not be wondering what they've done. Yes. Then 2.9 fourth quarter. When you substitute y, let me just show this again. We have 10,994 plus 13.5. We have, this is 14. We have it as what? 11,183 for 2020. First quarter, we have it as y equal to what? 10,994 plus 13.5. This will be 15. And we're going to have it as 13.5 multiplied by 15 plus this. We're going to have it as 11,196.50. And then 2020 42 y is equal to 10,994 plus 13.5. We're going to have it, this will be 16, and have it as what? 11 to 10. So you now adjust for the seasonal variation. Adjust for the seasonal variation. So same approach. Adjust for seasonal variation. So when you do that, you're going to have what? Let me just do that here. Let me do the adjustment here instead of waiting another. So seasonal variation adjustments. Seasonal variation adjustments. So for 2019, quarter 3, what will be the adjustments there? Check it. Check the question, you see it. Some people are just joining us. Anytime you see quarter 3, the trend has always been 6% above what? Above trend. 6% respectively above trend. So it's 6%. So you go there, 6% above trend is what? So these will be, depends. Some people can say 6%, it means 106%. If we divide it, 106 divided by 100, you have it in decimal. So I saw a question like that on the chat box some time ago. So for you to get the seasonal variation adjustment, you have it as what? 11,169.50 multiplied by what? 106%. You can divide, fine. Yes. And I think you should have here 11,840. this point, going to have for the fourth quarter, what has been the trend in the fourth quarter? 183. What is happening there in the fourth quarter? Check it. I'm just doing this because of those that joined. In the fourth quarter, what is happening? That fourth quarter, it's below trend. That is 9% below trend. So it means that this will be 91%. And you multiply, you're going to have 10,177. And for 2020, quarter one, we have it as 11,196.50 multiplied by what usually happened there, quarter one, 5% increase, that is 105%. And we have it as 11,756. And for 2020, quarter two, what usually happened based on trend, usually have 2% decrease below trend. So it will be 11,210 multiplied by what? 98%. And that will be what? 10,986. So this is what they want you to do for the B part. Now, if you look at the question, let's go back to the question again. Let's go back to the question. That's explain which forecasting basis produces the better forecast. Now, how can you know that? How can you know which forecasting basis produces the better forecast? How will you know? How will you know? It means which forecast contributes more results. And how will you know that? It's through your coefficient. It's through your coefficient. It's through your coefficient. How has seasonal variation impact on the cells? Based on the 10-period observation and the 5-period observation. So we'll use coefficient to measure that. And coefficient of determination is given in the question for 10-period observation, but it's not given for 5-period. This coefficient of determination is denoted by R squared, and it tells you how much the variation in the dependent variable is explained by the trend line. So now, how has this seasonal variation impacted on the cells based on the 10-period observation, based on the 5-period observation? If you look at the question, we have coefficient of determination. Coefficient of determination is given for the 10-period observation. So it is on this basis we are going to compare which is better. Now, we've seen coefficient of determination for the 10-period to be 0.535. But do we know for 5-period observation? No, we don't know. So what are we to do now? We need to present another formula that we can use to determine the coefficient of determination, which is R squared. Let me see if I have the formula here. Yes, I have it. Yes. Let me delete this. Okay, copy this further. Yes. So this is the formula to estimate the coefficient of the 5-period observation. This is the formula to estimate the coefficient. It's not far-fetched from what we've been doing. So the variables we need are already in the question. So for the 5 period now, to determine the coefficient, this is the formula we use to determine coefficient. Now, the n value is 5. The n is 5. I can see some hands up, or if you have a question, just type in the chat box, please. Just put in the chat box, please. Okay, thank you for responding to some of the questions. So, to get the coefficient of the 5 period observation, the coefficient of the 5 period, this is the formula to use. Now, the value of n will be what? Will be 5. Will be 5. The value of n will be 5. And the value of summation xy will be what? Summation xy will be what? I think it's given in the question too. It's given in the question.
Hello, sir.
Summation. Yeah, it can be too.
So, from the question, the equation that is given, I think it's a bit. That's one very different from your own here. Please, sir, can you go back to that your question slide? No, your equation slide. Equation slide. I'm using a icon and past question paper. So I just want to print.
Okay, the equation.
Yes, the coefficient of the determination.
Okay.
Yes, sir. The denominator here, the last one, is n summation s squared minus summation x raised to power 2. N summation y squared minus, I can say their whole here is summation s squared, s all squared.
Which one is that?
Yes, this one you are pointing at. The denominator, the last one. Yes.
This one here.
That one is correct. This one is correct. The last one.
Okay, this one
here. The next one. Yes, they said the summation x from their question.
Okay, from their own solution, right?
No, from the question, the equation they gave in their past question, the one at the back of the booklet.
Okay, at the back of the booklet.
Yes.
Okay. Okay. I have not checked that anyway. But this is the formula. Yes, for coefficient. So it's just this summation y, right?
Yes, it's just that summation y.
That summation y. Okay, I'll check that out. I'll check that out. But this is what I'll check that out. But this
and
is
sir, again, is all
Formula is
squared.
correct, sir.
It's all squared in the
Formula is correct.
All right, thank you.
It's correct.
All right,
but
thank you.
There should be a square root in the denominator.
Yes.
In the denominator, there should be a square root.
No, the square root will cancel out each other. That is why I didn't put it.
Okay.
Yes. Okay. The square root will cancel out each other. I know there are economists here that have played with this during their undergraduate days, and I think there should still be undergraduate economists in this platform.
Sorry, sir. Please, this issue of equation, it happens to me 2024 May when I was writing this out. the Hamilton formula they gave for PD in the question, that was what they said they should use. And it was different from what it actually is in the real sense. But when we are faced with this type of scenario, how are we going to do it? Are we to follow what I can give? Because when I now check their pathfinder for that year, I saw that they corrected that mistake. So are we to follow what they gave, or we have to use what we think is the best?
When you are faced with such scenarios and you are 100% sure of the formula, you are 100%, take note of my word, 100% sure, and there is no any silent issues that alter the standard that you know in the question. Take note of my words. There is no any statement that alter the standard that you've known, and you're 100% sure that this is the generally accepted formula. Hold firm to what you've known, and and say and put a clear statement. Do you understand? And it will be fine. Yes, because we're human. Even those that type can easily make error, and there can be an oversight even while trying to read and to read the question. So when you're very sure, it's not that we are not sure. Because last night I experienced some students, even when the result was out, they were trying to tell me that they want to sue ICANN, that they are very sure of what they put down, that they are this, they are that. I was just saying, just cool down, let's do this, let's cool down. So you must be very sure, man, that the formula, once you're sure that this is the formula that you know and it is the correct one, yes, use the one that is correct. If the one in the question paper is not correct, you ignore that place and work fine.
It's okay, sir. Thank you for the clarification.
So let's move on because it's almost getting to 10 and just so please, I think it has been justified that this is the correct formula, and so the value of EXY in the question is given as 4442.15, then minus summation X in the question. We've derived that to be 40. To be 40 multiplied by summation EY. Derive that to be what? 555.10 all squared. Then n is still 5. Then the summation x squared is given in the question as 330 minus EX squared, and this is 40. And we have this to be 5. And summation Y squared, we have it to be what? You multiply. You must be very careful when applying all this. You can see there are multiplication between. So when trying to write or compute, must recognize that. And then summation Y, you have it as what? The question as 555.10. So when you simplify this, please use your calculator to simplify this. Follow the rule of board mass, and then follow the rule of board mass. Punch your calculator. I know there will be many errors. Punch your calculator. Yes, if you don't punch it, you think you know it. It's a lie. There are issues. But punch that calculator and tell me your answers. Because I know some people will punch in a beautiful way. Yes, so when you punch, tell me what you have. Please make sure you're punching it. So what do we have? Is anybody getting 0.92? Okay, let me exercise it to patient. It's actually a very long one. I've jumped some steps, so don't just think it's your final results that I want to know. I've actually jumped some steps. So you follow the whole steps and give me the answer. Anybody there? Yes. If you're giving me the answer, just type in the chat box. Okay, Omolola, you have it right? Okay. Madam Dolapo, you want to say something? Adebayo, can you just message me on the chat box? Yes, why have arrived at this answer, 0.92. I need 5 response. 5. Just tell me on the chat box that you are there.
Please, I have a question.
What is the question?
Okay, please, after this, your formula, the first place you filled, I thought the raised to power 2 was supposed to cover this 5 multiplied by 4442.1 minus 40 times 555.10. I thought this raised to power 2 was supposed to cover all of them based on the formula.
Yes. It is actually, yes. Let me just adjust it. Sorry.
All right.
It covers everything. Okay, let me just add one. Yes, let me do something like this. Yes, see it. You see, you have two brackets now. You can see this is a bracket. This is a bracket, right? This is an outer layer now. The outer layer is having the square.
Yeah, I've seen it.
All right. So let me confirm again. Yes, we just need to get that, then we round it up. Let me write.
I don't think I'm getting the denominator right. Oh, sorry, sir. I don't think I'm getting the denominator right. I'm getting 49.01 and I can't seem to figure out my error.
49.01. Now, in the first part, 5 multiplied by 330, you have what? 1650, right?
Yes, sir.
Then 40 square is what? Minus 16, right?
Yes, sir.
Then the other
That's
part,
50.
5 multiplied by 627.40.
That's 308137.
Yes. Then minus.
And then when I do 555.1 squared, that's
Yes.
308,136.01 that I'm getting.
Yes.
And then when I deduct it from 308,137,
Yes.
my answer is 0.99. When I deduct that from 50, I'm
No, you
getting
multiply.
49.0.
You multiply. You
Multiply. Oh, that's my error. Thank you very much, sir.
So R square for 5 period observation is 0.92. R square for 10 period observation is what? Let's see the question. What is there in the question? No, R square, I said, is coefficient of determination, 0.535. 0.535. 0.535. Let me put a note somewhere. Somebody will ask me, how did we get, what is this? Note.
No, sir.
Yes? I'm with you.
Okay, good morning, sir. Good morning, everyone. Thank you so much for the opportunity. From this last step, I got 45.8329 as my numerator. So it's giving me a final answer of 0.93 instead of 0.92.
Yes, there will always be some little differences due to approximation issue. The point is this: just follow the step and get it right. Any question that involves approximation, just be consistent with whatever decimal place, and you are fine. Please, mark your steps, and think you're fine.
Okay,
So
thank you, sir.
R square is coefficient of determination. Let me put it in red. When you go to the question, somebody will ask me, for the 10 period observation, how did we get 0.535? Is in the question. Is in the question. See, it's coefficient of determination, 0.535. Now, explain which forecasting basis produces the better forecast. Explain which forecasting basis produces the better forecast. For you to explain, you use your coefficient of determination. The coefficient of determination to explain that. And that is why we have to compute for coefficient of 5 period to see which is better between 0.535 and 92 and 0.92. Which is better? You can change them to percentage to be 92% and 53%. Which is better based on seasonal variation? Which of this period experience more cells based on seasons? Based on seasons. So can I get response to that? Yes.
Sorry, sir. The denominator. I didn't get it. I was looking at, we've already worked the x, the initial one that is 50 minus the y. But I didn't get the y side because what I got was the triple 5.1 raised to power 2. I got 38 to something minus 61. I'm getting 24. Am I going to times the 50 times 24?
Sorry, I'm
trying to rush because
at what point you are referring to? Sorry, which point are you?
The denominator, the down. Yes.
So you want to
already
know
worked the first one, which is 50. The second part, which is for summation y, that's where.
Okay, this point here.
Yes.
Okay,
Yeah. Yes.
Y square. Y square. Is it given to us in the question?
Yes, it's given to us. Yes.
So 5 multiplied by 61627.40. What do you have?
Oh, sorry. Thank you. I've gotten it. I did multiply the 5. Thank you. Thank you. Go ahead, sir.
All right. So in trying to get the comparison, which is better, which have experienced more cells, is it the 5 period or the 10 period based on coefficient of determination? You use coefficient of determination to answer the point in part C. So can anybody just speak to that?
Is the first period. The first period is the best.
Okay. Why?
Because it's having 0.92 coefficient, while the other one is 0.535. So now 5 is higher.
Okay. So the period observation with the highest coefficient of determination, it's much more better. It's better when you want to advise the organization. Let me even see what they put in the ICANN Pathfinder. What is there in their response? Also go, please. Okay, so all right, that we can explain that 92% of the variation in cells by the passage of time using the former method, but can explain that only this variation in cells using the later method. Okay, so the 92% for 5 period is better off, and the compared to the 10 period observation. You see, explain which forecasting basis produces better forecast. So the 5 period forecasting basis produces a better forecast based on the computation. So class, another question I would like to solve in a morning class like this is the question on the local football club. One of the questions on risk and uncertainty. So if time permits, I will look for a day again to come up with that question and solve. So you can check the ICANN Pathfinder. There are some questions that involve the use of trend, but they might not be as complex as this and linear equation, but there are some questions with little elements of trend. Some they will just put T when T is 1, when T is 2, when T is 3. So, but once this is the basic understanding you need to have, and then any other question you see, please, your trend line equation. Know how to get the variables. Y is equal to A plus BX. Know what A is, know what B is. Where A is not given, know how to determine A. Where B is not given, know how to determine B. And your X will always be the observations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. There's the observations. So class, that is it for this morning. Thank you very much.
Thank you, sir. Please, can you go back to the solution? The last solution, sir.